This is the first video in section 6-1, and before I begin talking about the ideas in 6-1, I wanted to summarize briefly where we've been so far in this course and where we're going in chapter 6. So we began chapter 1 talking about the building blocks, some of the foundational ideas in geometry. We talked about points, lines, and planes. We talked about segments and angles and how they're related to each other. So some of the really the building blocks of the ideas and the things we're studying this year. Okay, we moved from there into chapter 2. We talked about logic and reasoning and deductive reasoning specifically. We talked about proofs, and that led us into theorems. Okay, we then moved into chapter 3 and talked about parallel lines and transversals and how all the angles that are formed. Okay, now specifically the same side interior angles being supplementary. We'll come back and we'll use that several times in this chapter, so keep that in mind. We also talked about in chapter 4 proving triangles to be congruent using side, side, side or side, angle, side. And actually in chapter 6, we could prove a lot of our properties and a lot of the ideas using proving triangles to be congruent, using the ideas from chapter 4. In chapter 5, we talked more about triangles, about altitudes and perpendicular bisectors and angle bisectors and other things about triangles. Now, in chapter 6, we're moving away from our study of triangles and moving into polygons, and more specifically quadrilaterals, which are polygons with 4 sides. Okay, so that's where we're going in chapter 6, is talking more about quadrilaterals and how they're related. So in section 6-1, we're talking about polygons and about the angle sum theorems. So by the end of this section, you should be able to find the sum of the interior and exterior angle measures of any convex polygon. You should also be able to find the measures of one interior or one exterior angle of a regular polygon. Or you could take the interior-exterior angles or the sum, excuse me, and find the number of sides that polygon has. So let's first talk about what a polygon is. So on the left, I have pictures that are polygons, and on the right are pictures that are not polygons. Okay, and one thing you might notice is that polygons are closed figures. Okay, so this is not a closed figure, and so it's not a polygon. Okay, this has curved sides. So polygons have to have straight sides. Okay, and the last one, which may not be as noticeable, is that polygons can't cross themselves. They can't overlap themselves. Okay, and those are the 3 main ideas about polygons. It's a closed figure with straight sides that doesn't overlap itself. Now here's a formal definition of what a polygon is. It's a closed figure made of straight sides, and each segment intersects 2 other segments at their endpoints. Now this second sentence is a little more confusing than the first, okay? And what that means is it doesn't overlap itself. So in the example I just gave in the last slide, this segment right here intersects not 2, but 3 other segments, okay? Which means it's overlapping itself. Okay, so which of these are polygons? Well, this is a closed figure that doesn't overlap itself, and so is this, and so is this. Okay, this has curved sides, so it's not. This overlaps itself and it's open, so it's not a polygon. Okay, this closed figure, straight sides, doesn't overlap itself, and so is this, and so is this. This has curved sides, this has curved sides, this has curved sides. Straight sides, closed figure, doesn't overlap itself. This is open, and so it's not a polygon. Okay, I hope that really clarifies what a polygon is. And those 3 properties of polygons. Now, just by way of vocabulary, things that you should be knowing, because I'll be using them, and you'll be studying this chapter. A triangle, you should know, has 3 sides. A quadrilateral has 4 sides. A pentagon has 5 sides. And a hexagon has 6 sides. Those are pretty well known. A 7-sided polygon is called a heptagon. Okay, an 8-sided polygon is called an octagon. That one's pretty well known. A 9-sided polygon is called a nonagon. A 10-sided polygon is called a decagon, and a 12-sided polygon is called a dodecagon. Okay, and anything else is as that number and then gone. So like a polygon with 14 sides is a 14-gon. A polygon with 11 sides is an 11-gon. So you just say the number and then gon. Okay, so here are some other vocabulary that's important for you to know. Equilateral, I think we talked about these briefly when we talked about triangles, but equilateral is a polygon where all the sides are the same length. Okay, now the word lateral means side, kind of like a lateral pass in football is a side pass. So equilateral is where all the sides are equal. Equiangular is where all the angles are equal. Equiangular. So all the angles have the same measure. Okay. Now, a word you probably don't know is the word regular. Okay, a regular polygon is both equilateral and equiangular, meaning that all the sides have the same length and all the angles have the same measure. Let's kind of look at this. Which of these figures are equilateral, equiangular, and which are regular? So this rectangle is not equilateral because the sides are different lengths. This one is, because it's drawn so. This one's not, because this one's longer than this one. Okay, this is, because all the sides are drawn to be that way. This one is, even though it's not equiangular. So even though the angles are different, all the sides are the same length, and so it is equilateral. And so is this. Equiangular, all the angles are the same measure. In a rectangle, all the angles are 90 degrees, and so it's equiangular. And this is drawn to be equiangular, so it is. And this one is too. Even though the sides are the same length, the angles are all the same. And this one is. This one is not, because these angles are not the same. And this one is. Okay, finally, which ones are regular? Well, if it's regular, all the sides have the same length, and all the angles have the same measure. So this one is not. Let's say this one is, and this one is, because it's both equilateral and equiangular. Okay, and I will end there for the first video.